All right. So in this session, we would be starting our discussion from Violin plots. Now, Violin plots is another quite interesting type of plot. More or less, it is similar to the box plot with a very exceptional difference. Now, with the help of Violin plots, you can also visualize the probability density of the data at different values. Probability density or the density of the data means where your majority value lies. Now, this is not possible with bar plot or maybe line plot or box plot, any type of data or any type of plot you form. The probability density is not shown. It's very just by visualization you cannot tell. Okay, this is the area where my majority data lies. All right. So to understand the density of the data, that where the density of the data my data lies, Violin plots are very useful. All right. So that's an ideal exception with Violin plots. They tell you the probability density of the data at different values. Like for example, you can very clearly see from this Violin plot that your majority data lies between this region. All right, a region which probably starts from 75 or something and ends at 110 and something. All right, similarly here you can see that, all right, your majority value lies somewhere from starting from 75, 80 and goes till something like 100. So this is how these broader areas are basically the showcasing that the density of the data is higher in this region. All right. So that's the benefit of Violin plot over box plots. Then there is a marker for median also, or you can very easily visualize the median values with the help of a Violin plot. Okay. So that's the additional benefit that Violin plot offers over the box plots or the bar plots. So it is very useful in that terms. So writing a code for Violin plot is very simple, exactly similar to box plot. All right, this code is exactly similar to what we have done in box plot in the last session. Again, we have generated these four datas like collection 1, collection 2, 3 and 4. All right, I told you the significance of using random.seed while you are generating random numbers in the last session. It's important that you use this code with the same value in the brackets if you want mine and your plot to be exactly similar, because when you're generating random numbers, the system can generate any set of random numbers. So my set of random numbers might be different, your set of random numbers might be different. So to keep them same, it is important to use this random dot seed code. So then I will collect the data in the form of a list, collecting all the four variables, then plotting the figure, drawing the axis, and then finally instead of box plot, ax dot box plot, I'm using here ax dot Violin plot, and I'm plotting the requested data. Now, if we draw it actually in a Jupyter notebook, so this is the notebook we have, the same code, all right, except this change that we are drawing a Violin plot here. And if you run this, this is the plot you will see. All right, just see how beautiful it looks. What is the biggest benefit of using this data? The density of the data at different values. I can very clear see that my majority data lies between this region, right? In this case, I can see that my majority values lies in this region. In this case, my majority values lies in this region. This is nothing. This is the density of the data, right? So my majority data exists in this region. That is the biggest visualization that you can get from a Violin plot. So if you are really trying to understand the density of the data, then you have to go for Violin plot, or you should go for Violin plot rather than box bar plot or any other type of plot. That is one of the very significant advantage that Violin plot offers over any other type of plot. And then you can very easily visualize the median value also. If you understand what median is nothing, it is the middle value in the data set. All right, so median is something which separates the upper half of the data and the lower half of the data. So if I visualize this volume plot, I can very clearly visualize that this is my median value, right? This is my median value, which is separating this upper half of the data and the lower half of the data. So the visualization with respect to mean can be very easily done when we are going for a Violin plot. Now, once you understand Violin plot, the next thing which you need to understand is the histogram, and especially when you're drawing histogram for a continuous data, a data which is in a continuity. Now, histograms are very, very important in the sense that they actually give you an exact distribution of your numerical data, how your data is distributed, whether it is normally distributed, if it is not normally distributed, then whether it is skewed, then in what direction it is skewed. That skewness, everything you can understand with the help of, or the kurtosis you can understand with the help of the histogram. Box plot offers similar type of feature, but it is used to understand the seasonality. Seasonality means, suppose the demand of crackers rise in the, in India, the demand of crackers rise in the season of, let's say, October, September, October, November, the Diwali areas, Diwali days, sorry. So now this is a seasonal change, seasonal fluctuation. Similarly, woolen clothing. So if you are living in India or some Asian continent where winters are for limited period, then you will find a sudden rise or sudden shoot in the demand of woolen clothes during those particular months. That's a seasonal change. So box plots can very easily show you that. Similarly, if you are going for probability density, we offer you violin plots, that you should go for violin plots. In the similar way, if you want to understand the distribution of the data as a whole without going into all this, extra stuff of seasonality or density, then you go for histogram. In a histogram, what happens when you use a histogram function? Your data points are grouped in the form of ranges, all right, or the class intervals, you can say. And the height of each bar will tell you that how many data points fall under each range. For example, let's say your range is 5 to 10. All right. So histogram will tell you that how many data points from your data set falls between the range of 5 to 10. It's so easy. That's how we represent histogram. You can specify the number of bins also that you want to draw. Otherwise, the function will take it automatically, right? So bins are basically dividing the entire range of values into series of intervals. So either you tell the function that how many, how you want to divide the entire range of values into series of intervals, or it will take it automatically. Okay. And the bins are usually specified as consecutive. Okay. Non-overlapping intervals of a variable. If you want to define bins, they are nothing. They are, you can say, they are just consecutive non-overlapping intervals of a variable. That is what the logic of bin is all about. Bin means dividing the entire range of values into series of intervals, and these intervals should be non-overlapping in nature, because if they will overlap, then the distribution will not be clear. It would be messy, it would be hazy. All right. So that is the benefits that histogram offers. If you are, if you want to go for histogram, or if you want to go for, the distribution of data visualization. So just a representation if you want to differentiate between bar and histogram, because in histogram also the bars are there. The height of each bar will tell you how many data points fall under that particular range. And if you are drawing a bar graph also, then they are obviously there are bars. But the very ideal difference is when you are drawing a bar graph, the on the x-axis you take the categories. I told you that bar plot, in a bar plot, one variable has to be of categorical nature. So that means your x-axis would be categorical. But in case of histogram, it is totally understanding the distribution of numerical data. So that means on x-axis you will have numbers, on y-axis also you will have numbers, and there would be no gaps between bars. In case of bar graph, there would be automatically some gap between each bar, but that is not there in case of histogram. So this is some ideal, ideal difference between bar graph and the histogram. So very simple to plot. There is no such rocket science when it comes to plotting. So you need to import the specific modules. Okay. Then defining the one by one grid. Okay. Then I'm generating some array of numbers with the help of numpy function. So this is my array of numbers. All right. 22, 87, 5, 43, and so on. And I want to draw a histogram. In histogram, you need only one variable because you're understanding the distribution, nothing else. So ax.hist, hist, that we need to use. Then I want to plot a, which is the array of numbers which I have already defined above. All right. Now I am specifying how I want my bins to be designed. So I told you bins means, what is a bin? Hmm? Bin is dividing the entire range of values into series of intervals. So either you tell the function that how you want to define these intervals, or the function will take it itself, your choice. Then if you want to put labels, then you can put labels as well. Okay, if you don't want to put the label, then you can simply specify the variable and the bins. Means instead of exactly telling the function that where you want to place your interval, you can simply say I want total 5 bins. So the function will automatically, process the interval. You don't need to specifically tell. So it is your choice how you want to go ahead, whether you want to just tell the function how many bins you want, or you want to exactly tell the function at what places, at what interval you want to design the bins. Then setting the title, setting the x tick values, again you can specify, or the function will take it itself. Then setting the x label and y label. So obvious, we have been doing it. Then the legend and the plt dot show. All right, so you will get a very beautiful histogram here. Like let's do it. So that's the histogram function I have. All right, let me remove this one. Okay, so I am telling that this is how I want to design my bins. Okay, I'm very specifically telling the function that this is how I want to design my bins. Or you can simply say bins equal to 5, 10, 6, 2, 4. If you want function to decide itself that where to take the specific intervals. So if you run it, all right. Now this is the histogram we get. All right. So as you can see, 0, 25, 50, 75, 100. This is how the intervals have been taken. All right. So I have specified that I want the my bins to be designed like this. So you can see in the diagram also, 0 to 25, 25 to 50, 50 to 70, 75 to 100. In the similar way, the bins have been designed. You could have simply told the function that you want 5 bins, then the function would have taken it automatically. So you can customize it in your own way, and you can understand that then how the variation of the data is there, how the data is distributed. All right. Uh, you can make certain customizations also, like for example, uh, mentioning the type of histogram. Now there are different types of histogram. Let's say, for example, the default is bar. This is a default histogram. It's a bar. Then there are certain other options or certain other customizations that you can do with histogram. Like you can say it should be bar stacked. So in this case, multiple data will be stacked on top of each other. We have already discussed what stacked bar chart is all about. Then it can be step, or okay. In case of step, it generates a line plot that is by default unfilled. Or it can be step filled also. That means it will generate a line plot and will be default filled as well. So let us try one. Let us now in this case I have mentioned that I want a histogram with type of step. All right, it can be any other thing as well. Let me move this second code which I just placed an example. All right, so let me run this code. Now you see. All right, so now in this case you are getting a line plot type of histogram and it is unfilled. Okay, so similarly way you can try step field, you can try bar stack. There are 3 4 options that you can try, or you can customize your histogram accordingly. So again depends how you want to present your data, or in what type of uh, customization you feel that your data is highlighting better. That totally depends upon you who have to present the data or understand the data. So in scatter plot shows the relationship between 2 sets of data. So how the 2 sets of data variate with each other. It's just like whether 2 data sets move uh, move in similar direction to each other or moves opposite to each other. So this can be very well visualized with the help of a scatter plot. We have discussed this earlier also. Okay? So it's a quick review. So let's say, for example, I have the data in the form of the grades that have been scored by girls and the grades that have been scored by boys. Okay. So this is my grade range. So I have defined my grade range here. I want to plot scatter, so I will use ax dot scatter. Okay. So grade range. This is my complete range of grade, which can vary between 10 to 100. Then I want to plot uh, girl grades along with it. And then similarly in the another scatter, grades range and the boy grades. Okay, I have labeled them differently and I have colored them differently. Then setting the X label, Y label, and the title. So if you see, it's quite easy, quite straight code. Okay, so that's the boy grade, the girl grades range, then the scatter plot between grades range and girl grades, grades range and boy grades. And if we run this plot, we can see how it goes. Okay, so the red dots are the girl grades and the blue dots are the boys grade. So on the x-axis we have the grades range, and it is showing how the grades of boys are varying with the grades of girls. Okay, so that's what a scatter plot can help you with. That is understanding or uh, analyzing the relationship between the two sets of data. So we can see that the grades scored by the boys is on the lower side, while the grades scored by the girls are on the higher side. Okay, so that's we can see how the two things are in context with each other. Okay, so that's all for this session. Thank you so much and keep plotting.